The universe is calling you. The universe is calling me. It speaks both day and night. It's full of dark and light. And I've heard others call from light years away, and they're real and they're here. Space and time are instantly clear. Planets spin, grids in place. We can travel through space, fields and forms, math and voids. It all sings with one voice. It's boundaries set, foundations laid. Sound was heard, matter made. Solar systems from afar. Names and numbers for the stars, and I've heard others call from light years away, and they're real and they're here. Space and time are instantly clear. Planets spin, grids in place. We can travel through space. It's the Lord's.
Well, well, well. Hey, everybody. Welcome to SkyTour Livestream. It is I, Mark D'Antonio, here with Daryl Mason. Daryl, how are you?
I'm fine, thank you. How are you, Mark? Hello, everybody.
Doing just fine, just fine.
Got a frog in my throat.
Yeah, well, we have frogs around here, too. We've got the peepers are out there, which are crazy, wreaking havoc on everybody's peace. They're so noisy. I love it though; they're cute. So, a lot happening. Marianne and Tara went out to the observatory today and did some major upgrades. We scrapped the entire circuit that was running the telescope. I built a new one here, and I sent it out there, expressed priority to send it out there so they'd have it, because I wanted them to be able to install it and it's streamlined. It's hardened, battle hardened. And in fact, during the installation, Tara actually accidentally dropped it on the floor, and the circuit was none the worse for the wear, and it worked just fine. So we're happy about that. All right, so now we're streamlined. Things are working great, and we also installed a bird deterrent because, unfortunately, see, this is our nighttime view right now. This is our all sky cam right there. All right, and I only have it set for 15 seconds because the moon is rising. There it is right there. It's up. And so we want to, moon's already rose. So we want to basically keep the exposures low so we just don't blow out the sky. But we have all of our constellations available to us. We can see the constellations. We have our time-lapse images from previous days. These are all things that you'll eventually be able to get with us to see. We have our star trails too. Like these are the star trails from the last several days. Obviously with the moon you get a lot of very bright ones. There was a time where we weren't getting star trails, and that's because I had a threshold value set improperly. It was working and then it stopped, and I don't know why. I don't know why the threshold changed, but it did. I fixed it. It's running now. And our telescope, or the system out here, that's our location. We have a ZWO ASI 678 camera, and we're using a version of All Sky that comes from Thomas Jacquin, which is an amazing developer. And you'll notice we don't have any bird poopy on our dome. That's because our bird spinny, as we call it, is keeping everything off. So good. So I'll leave this in the background. Okay, this is Spica. We're at Spica because even though it's a full moon, we're going to be going up to look at the comet, which is right nearby. It's that comet that we have been looking at lately. I think you guys know the comet. It is this comet, Comet C 2023 A3 Suchinshen Atlas. And we will be checking it out in just a moment here. Now that we have some pretty dark skies, I took the liberty of putting the coordinates in over here. For those that are just joining us and don't quite remember everything that we have going on here, this here is the telescope block. Okay, it's the telescope control block. This is the telescope computer. These are the views of the telescope. This is the view of some dumb guy that just keeps talking and won't be quiet. Here's the main view. This is the camera control cluster over here. The most important values are here. We have the gain and we have the exposure. Gain and the exposure are the two most important values. So we'll check those out in a little bit. These are the focus area down here. So that said, let's actually tell this telescope to go to the comet location, and we'll check it out.
You know, tonight would not be a good night for it, but seeing on your all sky where Spica is now.
Yeah.
We've looked at the antennae galaxies in the past.
Yes, we have.
They're probably prime time right now. As soon as it's dark.
Yeah, I bet you that's true. I bet it's true.
Remember, right there to the lower right of Spica.
Yeah. Okay,
I see a comet.
You do?
I think so.
Yeah, you do. It's right there.
Right there.
Yeah.
Marianne is here.
Marianne is here. Hey, Marianne. Marianne
Hero.
is building up a full house. She's a hero, all right, because she and Tara went out to make all this possible once again tonight for us. Show them some love. Marianne installed the spinner, which is going to keep the birds off of our dome. I'm going to be ordering another dome, Marianne, just so you know. I have to, because the birds have scratched up the one that's out there to the point where it's a little bit difficult to deal with, but I can deal with it. Don't worry. I will put on my big boy pants. Don't tase me, Copper. As you know, she's a police officer. What?
Get a glass dome.
Yeah, I was thinking of a glass dome. The only problem is it has to have holes in it for mounting, and plastic domes are cheaper, easier to manage, and the glass can still get scratched.
Well, all those points are true.
Yeah.
Uh, Maybe do like NASCAR, put some of those peel away
Oh yeah.
windscreen
Yeah.
stickers.
I was wondering about those, but on a hemispherical surface, it has to be made like balloon gores, and you'll see
Yeah,
the seams.
yeah.
But I thought about that too, is have a clear peel away, anti poop thing or whatever. But I also have my thing here I've been working on, which is the windshield wiper for the top of the dome. And so I wrote the program, and if it detects a bird coming, I have an ultrasonic pair of detectors, and if it detects a bird coming toward the dome to land on it, I have this fake hand that'll go up and go bleh, and get in the bird's face and like scare him away. But now with the possibility of modifying it so that if I want to wash it anyway, because you're going to get dust and stuff up there, I'm going to probably end up making a windshield wiper, a curved wiper that'll just go and go and just wash and have water too. It's going to have little water jets like we have on our cars. I want to say hello to Randy and Diane. I want to say hello to Stan. I want to say hi to John. Stan is having a birthday, and on May 25th, we're going to all be getting together in Arizona. I'll be leaving tomorrow to go out there and see him. It's the reason I'm coming out, Stan, is to see you early. Otherwise, I would have gone a little later. But with you involved, you know what? Sky's the limit. You're an excellent, wonderful human being, and you've served everybody so well, especially on the reservation with the Navajo people. You and John worked together with you, those guys. Those guys worked together for, I think it's 25 years. Am I wrong? Let me know. And that said, Stan has a book out, and it's about his incredible life and strange goings on in the paranormal. And I believe the book is called Paranormal Ranger. But please let me know. And that's Stanley Milford, by the way, Jr. And Stan is I'll see him in I'll see him tomorrow night. Well, he'll be asleep by the time I get in. Tara's here. I beat you to it. Hello, Tara.
Hi, Tara.
Tara's here to see the fruits of her labors, too. And look at Tara. Tara is here. Show Tara some love. Show Marianne some love. Because the two of them went out today to the observatory and actually fixed the problem. There was a circuit out there that went bad. Tara fixed it like a trooper. I darn well think she could do anything in that building now electronically, I'll tell you that. All right, we're going to set the time here to be 12 seconds. And it's probably going to be, the time is set here. I have a little weird time here. I'll move that in a bit. I'm going to set it to 12,000 milliseconds. And we're going to say to go. And then we're going to stack this and see what we get. With the moon, it's going to be a little bit odd for sure. All right, so let me get rid of. Let me take the time and move it. Okay, hang on. Here we go. Yeah, a little bright here because this guy's got to come down. And boom, and there's our comet.
All right.
Here's the comet right there. Actually, it looks pretty much the same as from last time. You know?
Yeah.
I'm
Still
going
pretty
to,
far away.
It is.
Get a lot brighter and closer.
Yeah. I'm going to immediately improve the picture with this little click of the button. All right, and then right now you're seeing a little haze of the sunset red light here. That's what this is. Because right now the sky's got a haze of red that is kind of difficult to see, but it's there. All right, so now let me come back into here, the hologram, the histogram, and I'm going to pull this down a little bit just to give us a little more of the contrast, and then move this up to the dark level up to kind of bring out a little of darkness. You'll see that the comet looks like that. Over time it's going to move. All right, we'll see that the comet's going to move. It always does. It moved across the sky this way, and I believe that's a galaxy right there that it's heading toward. I wonder how close it's going to get to that. That would be a wonderful picture.
Maybe.
Yeah. Okay, we're going to call this Comet C 2023 TSU Shinshen Atlas. All right. Okay. And let's color correct and see if we can correct for that red a little bit. That's a little better. Not bad. We already focused, by the way. I do want to come over. I've been remiss. I apologize, folks. I wanted to say hello to Renee Cruz, who was first to come in. Hi, Renee. Stan at Two Rivers is with us. Two Rivers Observatory. Stan, where is Two Rivers? Let me know. And Michael Glee is with us. Hey, Michael. Karen Belmont is with us. Hi there, darling. How are you? Nice to see you. And Renee also mentioned that a good friend of mine who has passed, Bruce Maccabee, a fixture in the UFO arena for doing photo analysis back when they were using film. Bruce was instrumental in moving MUFON forward by leaps and bounds. Big shoes to fill. So it's rough that he has gone. My heart goes out to his wife, Jan. And so let's see now. C&D Boy is here. Hey there, C&D Boy. Christine is with us. Christine said hi to you. Sam S is here. Hi, Sam. Yeah, and then Rocket City Astro. What's going on, man? Did you know this comet was out there? You should get your scope out and look at that comet. I think it's still in Virgo, isn't it?
I do believe.
Yeah. Yeah. And then,
I
of
didn't
course...
see Christy.
Yeah, Christine. Chris space.
Oh, yeah,
teen.
okay. Yeah. I get it.
Yeah. Yep. Keith Evans, hi there. How are you? Nice to see you guys. You know, if you guys like what we do, you can always support us if you like in our Patreon. It's helpful. Cosmic Ray is here. And being as curmudgeonly as always. Yeah. Alright, so let's see. Let me do one thing here. Let me get this time and date thing. I'm going to take the time and I'm going to move it up right there, and then I will close the grouping, and I'm going to make it invisible because it just gets in the way. So that said, let's correct again. We've got 22 shots here at 12 seconds apiece. That's good. We're using a filter, which is actually quite nice. It's a bright sky out there with the absolutely full moon, but we can still see this faint comet. And this central brightening has to do with two things. First, it has to do with the the remains of the sunset light that is still affecting us a little bit, but mostly has to do with the imbalance of the flat field that we're trying to do to reduce the brightness of the moon and make an even view across. So maybe what I can do is I can look at the flat that we're using, which is 1911-21 from 9/6. And let's do this. Let's clear this, and we're going to use this. I'm going to take the flat off and see how that's going to look. I'll say none for now, and then I'll save it, and save it exactly as seen. Okay, so now it's saved exactly as seen. Now I'll clear it, and we'll do it again. And let's see how it looks different. The moon is going to throw off the flat fielding where you try to make everything even. Yeah, that's going to be a little better, I think. When the moon's out, we take out the flat field, and now we get our comet. And I'll move this back a little bit. Yeah. All right. When the moon comes up a little higher, we might even look at it.
Mighty bright.
I know it. We'll prepare. We'll reduce our exposures accordingly. See, right now I have my sensitivity, the gain that's over here, guys. The gain, as I mentioned, the gain and the sensitivity are actually the two, the gain and the exposure, okay, are the two most important fields for the moment-to-moment use of this telescope, because this is how long we're going to expose and allow light to hit the sensor, and this is how sensitive we're going to make the sensor, the gain. So you play with these two things to get the best combination. Right now the gain is 150. It can go as high as 400, and we're using lower gain because we're not going to be looking at anything that requires high gain, long exposure stuff.
Can't see the K just behind that blue bar.
Well, they don't see that. You do.
Oh. Aren't I special?
You are. You're seeing all the behind the scenes stuff. Yeah. Okay, so let's color correct and get rid of that red fringe if we can. Oh, it made it worse. Okay. Oh, duh. No, it didn't. Alright, so now you got that. Alright, so now what I can do is I can color correct. Get rid of that fringe. Okay. Yeah, it'll get better. Okay. So it's a very calm night out there. The winds are not bad at all. Hey, Izabela.
Isabella's here. Hi, Isabella.
Yeah. Yeah, so this is good. And we're going to be doing... so let me just give you the lay of the land here. Tomorrow, I'm flying to Arizona. I'm not leaving until 6:30 p.m. I get there at 10:30 p.m. Arizona time. So, first things first, go to bed. Then wake up and get involved in having a wonderful party for Stanley Milford, Navajo Ranger, who, along with his friend John Dover, served the reservation community for decades as Navajo Rangers. And Stanley wrote a book called The Paranormal Ranger, I believe. And he is going to be at Marianne's house for a birthday party for him. It's for his birthday. So I was invited, so I'm going. because Stan's my friend. We're good friends. I'll do the same for you too, John, when it's your birthday. So that said, we'll do that, and then Sunday, if necessary, I'll head out to the observatory, but I may not need to because Tara and Marianne have done a bang-up job. Then Tuesday, we are heading to Tucson to pick up the new telescope and 2 new mounts. One for this telescope and one for the new telescope. And the new telescope will be a Celestron 11, and that one is not going to be a hyperstar system at this point. It's going to be a system that is going to be at its I think we're going to make it F7 or something like that. I got to look and see exactly, because we're using a focal reducer, take it from its native, I think it's F8 or F10. I thought it was F8, but you said F10, Daryl. I don't know.
The native F ratio?
For Celestron 11.
F10, I think.
Okay.
I know they actually, I was reading something just the other day. Maybe you showed that, or where did I see that? Oh, I saw it at Dylan O'Donnell. I'll talk about it in a second. They do vary some. They're not all F10. He was talking about getting a Rasa versus a hyperstar.
I saw that.
He said some interesting things. I guess they're up to like Mark IV on the hyperstar now.
Yeah.
And some of the Celestrons are like about an F1.9, some are F2.
Mm-hmm.
I think it was the 9.25 is it's like F.225 or something like that. And
Okay. Well, I think that I cleared it, and I'm starting again, guys, just on this. Once it's fully dark, we're going to go look at some other things. But the thing is, I think that the C11 is going to be running at F6, is what I thought I remember talking to Steve Koenig, the owner's son, about. But I'll check on all that. Anyway, so we're going to pick that up. And we're going to, you know how this telescope's got forks, it has forks on it? You can't really tell, but you can kind of see there's one fork here, there's one fork here, and there's a base here. And this whole thing rotates around, okay? And the telescope goes up and down in between the forks. Well, that's problematic because the Meade system that we have, you can't get parts for this anymore. And it's the only Meade in the world that is running a hyperstar on it. There's no other Meades with a hyperstar. We're a prototype. And this particular Meade is not doesn't have replaceable parts. If something goes wrong, we have to bring the entire telescope down to David at Star Arizona, and David is a fantastic Meade technician. And what he'll do is he'll go through the circuit board and trace by solder spot, find the problem and fix it. And he's done that twice now on this system. And I'm sick of having to fix it every now and then. So that said, we're going to replace those forks. We're going to have the tube itself. We're going to mount that tube on a new mount that's going to be called a German equatorial mount. In particular, it's going to be the Skywatcher EQ 6R Pro. And that mount can hold all this weight easily with no problem. And then we're going to have a guide telescope that does what this telescope right here is doing. That's a separate guiding telescope on this telescope. And then we're going to have a second one on this system with a little guide camera on it. And we're probably going to get better performance than we get with this telescope, believe it or not, as it is. So, that said, that's going to be Tuesday. And then we're going to get that all back to the staging place where all this is going. And then we're going to head to Palm Springs. We're going to drive there. We'll be bringing Kriston T. Harris with us. And he does the rundown live, and I've been on the show a few times. And then we go into Contact in the Desert. Now at Contact on Friday, I'm doing a lecture. The lecture is going to be how UFOs get here from there, the real physics behind how they can be here. And it talks about, I say real physics, it's foreseeable physics. And it has to do with dimensional travel. It has to do with Kaluza-Klein gravitons and the whole KK hypothesis. And it's been well received everywhere I've done it in the country. So I'm going to do it there. And that's lecture number 1. I've got 3 to go. And then the second one I'm going to do is a sky tour. We're going to have a live audience, and we're going to have it broadcasting to the world as now. And so you'll all be treated to the din of people talking in the background. And I have a different webcam that'll show you the people watching. So you'll see the audience, as well. And then on Monday, I do another talk, which is basically it's a talk which is going to illustrate the real way in which we find life in the universe, and that we will find life in the universe. Talk about the latest discoveries, and then we're going to talk about the history of the Earth and why looking for planets out there, we can expect to see them at any one of those stages of evolution. And that lecture is gonna end with my, I guess now famous, I have to call it, toilet paper history of the Earth. People love that when I have that on there, when I do that. So it's kind of fun. So, yeah, thanks, Ray. I thought that's right. I thought it was close to that. It's gonna be an F7 because it's. He says it is an F10. It'll be F7 with the focal reducer. And I am getting the the full field focal reducer, by the way. So I will have that. He says there's at least 4 other Meade 10s with Hyperstar fitted. I haven't seen one, to be honest with you.
I've heard of at least one other.
Okay. Well, Star Arizona told me that we're the first anyway, so that's for sure. I know that. Yay, we got something. Well, people follow good things, right? If they see something cool, they'll do it. But I don't think that the Hyperstar would be beneficial on the 11 because we want to do a system where we can actually looking at this comet. We want to be able to have the comet be, bigger in our field of view. We might be here's what we might get. We might get something. Our field of view might be like this when we do the F7. So that'll be pretty good. That's what I'd like. Maybe even a little smaller.
I think yours will be F6.3, didn't you say?
I thought so, but I have to talk to Steve and find out at Star Arizona what the exact number is going to be. It's going to be a little photographically faster than the F10, yes. So that's pretty cool. Yeah, Roy Batty, toilet paper history. Yeah, what I do is I put the entire history of the Earth on a roll of toilet paper. Now it's 117 feet long, 300 sheets, 4 inches wide each. What I do is I put all the many developments that occurred on the Earth from the time it formed to where we are in that room today. So I'm always updating it. And so I literally unroll it out in the audience. I go out in the audience and do it. And I have people hold up different things, like people hold up when oxygen formed 2.5 billion years ago. And they see a whole lot of nothing happening all the way up until the last 20 inches when we have an explosion of life, starting with the Cambrian era and leading into the Permian era and then the Jurassic era, Triassic, and then we have the Jurassic, and then we have the the modern era right now, for where we started to see hominids. And I talk about all that And people are very, very, very fascinated when they notice that dinosaurs died on that scale of 117 foot long history of the Earth. Dinosaurs died 18 inches ago. Okay? Literally 18 inches ago on that scale. So in other words, they're recent history on the Earth and not ancient history. Kind of cool. Okay, we'll save this again. And maybe we can move on now.
I saw somebody do that in junior high school.
Was it me?
No.
I know. All right, cool. Yeah, no, it's great. I'm doing one for the age of the universe now. The only problem is, or the history of the universe. The only problem is I can't be certain that it's 13.8 billion years or maybe 26 billion years old. There's some thought processes indicating that maybe because of what the James Webb found with fully formed galaxies only 300,000 years after the beginning of the universe, that it found that maybe they were around longer, or we got something really, really wrong in cosmology. That's why I'm not a cosmologist. That's why I'm an astronomer.
I gave up on cosmology a long time ago.
Cosmology is more philosophy.
Yeah.
In a sense, but I agree with you.
It's navel gazing is what it is.
Well, maybe.
But anyway, I'm a oscillating universe, yin-yang kind of guy. I found it aesthetically pleasing.
Yeah, I found the oscillating universe to be interesting. We had the oscillating universe, we had the steady state, and we had the expanding. The data shows that it's expanding and accelerating. So oscillating universe is nothing that we can show right now because it's the universe is expanding and accelerating. So there's going to be a point where it can no longer collapse upon itself.
Yeah, so they'd say no.
Okay.
I think maybe, Webb is changing everything. The
It
Webb
sure
telescope.
is.
And,
It sure is.
that's where the 26 billion year old universe idea came from, I believe.
Yeah.
Plus the 300,000 year old galaxies. And they're going to have to. It'd be interesting to see where they are 20 years from now. They're going to have to rewrite the book on everything.
I agree. Okay,
and I bet those cosmologists are lying awake in bed at night trying to figure it out.
They are.
Yeah.
They are. I think this is the M53. Let's go check out M53 with our full moon night. Okay, so as you can see, here's where we are in the sky. I'll back out. All right, there is the telescope right there. The moon's down here. Right now, if we could only look down there, we'd see the Omega Centauri cluster.
Yeah.
But we can't look below the wall of the building. But with the Benson telescope, we will be able to see it without fail. I may still modify this mount to put in one of the lifting columns so that we can lift the telescope and have it see down there. It only has to move about 8 inches, and the lifting column could go, I think, 14. So it wasn't a miscalculation. We needed to do it at this size. So whatever we figured, whatever size we're stuck with that we must do, we'll make sure that we just get the best for our bang for our buck, And we did spend lots of bucks on this. Okay, let's go back now up into Coma Berenice's hair.
If you do M53, you ought to do M3 too.
Yeah, it's right there.
The two. They're both globulars.
Yeah, that's where M3 is right there. We'll do M53 first.
Oh.
All right, so let's go back to our live view and get rid of this. And now we'll pick our interval time here to 1 second, and then go into our low light mode. That's good. Okay, low light mode coming up. There we are. And now we come back to our planetarium. M53, center it up, and go there. You can watch the telescope move now over my head. Okay, here it goes. It's now moving right there. It should have M53. There it is, right there. That smudgy thing. Yep. Okay. So let's now move to the west with the telescope to center up Measure 53. Here we go. And then we'll move south to raise it up into the middle of our field. And we can basically look at our finder view here. This is kind of fun. Bring it up. Dead center it if we want. Get close anyway.
I think Michael H. has a crush on you.
Why would he say?
He put up a bunch of hearts.
Well, he just loves this. He loves this. This is great. Thank you, Michael.
He said Mark, though. And he even capitalized your name.
So how are you, Mark? Hello. Well, he's saying hello, and he's maybe that's his way of saying love it. This is so cool, and I can't disagree with him. Thank you, Michael. You are a consistent person who loves to come and watch what we do, and I absolutely am happy that you get a lot out of it. A lot of people do, and it's wonderful. It's catching on. People are actually starting to call now from all over the place, and I just did 9 spots on Coast to Coast Radio, AM, Coast to Coast AM, yesterday, I think. And did all 9, and it was with Ron Janix, who is the co-owner of Contact in the Desert, and Ron has a new podcast on Coast to Coast AM. And that podcast delves into the universe and some cool things, and UFOs, of course, interstellar travel. And so that was kind of neat. We're going to do a 15-second shot here. There we go. And we'll go into our live stack. We're going to reduce this here. We don't need that right there. And we're waiting for our first image. Hey, Your Story, how you doing? Mexico Beach, Florida. That's cool. Oh, look at that. Measure 53 looks really pretty tonight. Let's color correct that green out. There we go. Now let's actually add a little dark contrast. Pull this down a little bit. Here we go. See, we can already zoom in on this. Let's see how our stars look. Look at that. Look at that beauty. Wow. In our filter here, this full width half maximum filter, you can see this number represents how much we allow the stars to go out of round. And right now it's staying under 6, or it's staying about 6, so I can even drop this down to like 6.86 and it will be fine. And you can see the stars are round. Really pretty. Oh, Starlink. Zoom. Okay, let's move the dark level up to really add some contrast here.
The full width half maximum thing, that's basically an analog for how windy it is, correct?
That's what I've been using it for, because it could also be an analog for drive error, driving correction error. So if the periodic error, see, there's worm gears inside that are slowly turning. And I think in this particular telescope, every 6 minutes they go through a revolution. And if they're out of round, or if there's some debris or dirt in there or whatever, you can get a periodic error that will mount every so often and then go away. And so the full width half maximum approach here, we might get a number that comes up to like 7 or 8, and it'll be above our threshold, and you might get 3 or 4 of them in a row, depending on how long your exposures are. And then it would go back to all greens again. So we can actually weed out bad drive correction problems or wind, as Daryl just said. Let's see where it wants to be. It wants to make it a little brighter. I'm going to move this down, because that way we can resolve what's inside the cluster.
Folks, take note of the character of this globular cluster, how dense it is, how tight or how loose it is, any particular markers in there, things of interest. When we go to the next globular M3, I bet you they're going to look quite different from each other.
Yeah, and one of the reasons will be distance.
Heck, you can probably catch Hercules by now, can't you?
I might be able to. I'm going to see if we can do that too. Michael Hedrick caught some really cool pictures of the auroras, as you know we did too. My son and his girlfriend did they took a picture, a selfie against the auroras in the background here. And he's very clever. He called it Selfie Borealis, which is really cool. It's really, really pretty picture, really cool.
They had a sighting as far south as Hawaii.
Oh yeah.
My sister there was looking for it, but it was raining where she was. It was like 18.2 degrees north latitude.
Yeah,
They
right.
saw it from Namibia in Africa.
Yeah.
They had some really bright and obvious ones, even that far. Well, that's southern hemisphere, so it'd be how far north it was, I guess.
Well, keep in mind this was a G4 event, not a G5. A G5 was be a Carrington level event, and this one didn't really blow out any electrical grids, really, as far as I know.
Knock on wood.
Yeah.
I've said this before. If you've never seen Connections by James Burke, classic science documentary about the nature of change.
Mm-hmm.
The very first episode, I think it's on YouTube. The very first episode, he talks about when the power went out in New York City.
Oh yeah.
He shows a relay in his hand. The relay failed and the power fell out. And he carries on to talk about, what if the power doesn't come back on? What are you going to do? And he winds up in a barn out in the country, up in the hayloft, and there's an old wooden plow. He says, this is what it will boil down to, is this wooden plow. Do you know how to use it? Do you know when to use it? Will you be able to protect your crops from raiders if you do manage to cultivate one?
Mm.
That's nature red in tooth and claw.
Yeah.
If the Carrington event happened again.
Yeah. Well, with our grid exposed like it is in the satellite environment, is vulnerable. But we didn't lose any satellites from this, which is kind of cool. Your Story says, this channel is freaking awesome. Hey, man, thank you. Hey, thank you so much, And hey, it's all free, brother. It's all free. Make sure you subscribe, okay? And hit the bell and drop down that bell dialog box and say all notifications so you hear from us, okay? And I'm going to change the name on this here to M53 and I'm going to say GC after it because it is a globular cluster. Globular clusters like this, these are halo objects that we've talked about before. And in our galaxy with its spiral arms, these guys are those outliers that kind of orbit around the whole galaxy as a whole. And they can also plunge through the disk and then circle around and plunge back up through the disk. And during that time, some of these outer stars may be shed and left behind, or it may be picking up some stars from the disk as it comes up through. So there's a possibility that the pristine nature of these stars in here, which are among the earliest stars in the universe, would actually have a little bit of pollutants in them, a little bit of metals, I should say, besides hydrogen and helium. Because when these stars formed, there was no real magnesium that was made in the hearts of stars by then. There was no calcium and phosphorus and potassium. Okay, there was only hydrogen, the most numerous, the most abundant element in the universe, and there was helium, which was a product of hydrogen fusion. So we didn't have a lot more than that, and maybe some lithium isotopes in these stars, okay, because they're amongst the earliest stars there were. So that said, globular clusters are probably places where there's, I would guess that there's no planets, because there's no planet making material being made there. Maybe after these stars die, okay, and once they die and return a lot of their elements to the interstellar medium, then perhaps something can happen. But right now, they're really a pretty sterile environment. Although to be on a star system in the globular cluster would be really phenomenal, because you would have stars, bright stars around you, all around, that would be kind of relatively homogeneous distribution. So it'd be kind of cool to see. You know? Okay, so this is our Measure 53 globular cluster. All right, we'll save it and save it exactly as seen. So we send an astronomical file out there, a FITS file. For those of you that know how to do image processing, you might want to try your hand at it. You're more than welcome to. It's free to take. And then we send out an astronomical, well, a ping file, and I'll show you what the ping file looks like. This is what's out there. This is the exact thing that is being saved. Now, where is it being saved? It's being saved to our server. Where's our server? It's at, you can go to skytourlive.org and scroll down till you get to the section that says I want to see cool pictures, and it will describe for you what to do. We also have an app that we're working on right now, and I should say that Izabela Melamed, who is in our chat tonight, she's from Bulgaria, that Izabela has put together. She took it upon herself to take and create this most amazing app for looking at every single time we looked at something in the sky. You can look up globular clusters, you can look up nebulae, you can look up all kinds of objects, planetary nebulae, Wolf-Rayet stars, emission nebulae, reflection nebulae, dark nebulae, or you can just sift through it and go to specific types and pick only those types and look through all the many globular clusters we've found, all the many planetary nebula we've seen. And this is from and that's called the SkyTour Stargazers SkyTour Stargazers Companion. Okay, Stargazer Companion, and it's it's really cool, and we have it. It's for the PC, and we'll have it for it can be PC or Mac, and it'll be available for Apple and Android at some point. We're actually working on those now. We have test apps now, and they work really well, and we have a little front end that we can use that Izabela put together, and it's quite nice. Okay, I'll say this one more time. And we'll go to measure 3. So take a look at this. All right. And so up here at skytourlive.org, you can find the pathway to get to our server, and you can take these down. You can take down these pictures just if you want, just like this. I want to say hello to Jason. How you doing, Jason CLJ? What's going on? Let's see. All right, nice to see you. Papa Tom's with us. That's good to see you. In Boxster, what's going on? How are you? Thank you for coming by and checking us out. And I think I missed Genghis. Hey, Genghis. Nice to see you, brother. Yep. And I think... yeah, then Mr. Django checking in from Belgium right now. How you doing? How you doing, Mr. Django? That's Steven. How you doing, Steven? Nice to see you. Okay. And D. Smith is with us. Look at that. Hi, D. What's happening? Okay. We're going to take this one down because we're now going to head to the next one. This is... You got to look at this. All right. We're just going to... I'll leave it in the buffer. Okay. So we'll have it in the buffer. So when we come back, you'll see it in the buffer. But what I'm going to do is take us now to measure 3. All right. So here we go. We're going to go into our low light mode. And let's go to measure 3, which is right over here. M3. Center it up and go. All right. Measure 3. This one is 32,000 light years away. And when we look at measure 53, okay, its distance is, I think its distance is, let's say, looks like it's pretty far here. Let me see. I can't read it with all this stuff in the way.
18,000 kiloparsecs.
Yeah, it looks like 58,000 light years. 58,700 light years.
Yeah.
Okay, so let's now go to measure 3. Okay, measure 3 is literally about half that distance. It's 32,600 light years away. All right, so we'll center up on that and head there now.
And if we go to Messier 13, I forget, what's it, 13,000 light years away?
Yeah, it's big.
So, yeah,
all right.
Yeah, big, close.
All right, so there's measure 3 right now. And we are a little zoomed in right now, but that's okay. That zoom is just artificial. I can take us back to like this, you know, and zoom out until we actually see the whole frame. There's the whole frame. Okay, so what we'll do now is going to head to the west a little bit. All right. See, even with a full moon, you can have some fun. Okay.
When we see Messier 4 globular cluster in Scorpius,
That's even
it's
beautiful.
right next to Antares in the sky, not really. But it's the closest globular to Earth. I think it's like 4,000 light years away.
Mm.
And seems to me that if it's that close and in the same line of sight as Antares,
Yeah.
I would think M4 is actually inside the galaxy, not out in the outskirts or the halo.
Yeah.
I could be wrong.
Well, it would certainly have to be in the process of passing through.
Yes, sure.
If it's close enough, it certainly is. It's in the direction of the galactic center, so it's definitely along that line of sight. Okay, let's now do a similar 15-second exposure of this guy. Okay. And I'm going to take us off of here so that when we go in, you can see our progress bar is now moving up over here. So we're going to go in. We'll see Messier 53. Okay. There's 53. Now we'll clear this. And you'll see Messier 3. And there it is.
Bigger and brighter. Looks
Yeah.
a little more concentrated in the center than 53 did.
Well, you can see that it's closer.
Yeah.
It's, you know, that area around the center. Let me just go do it. Okay. So this area right here in the center, okay, you can see this area here in the center is actually bigger. All right, this bright patch, and so that's actually bigger in Messier 3 than it was in 53. 53 was more compact. Okay, it's about like this compared to this. And this is almost twice as close to us as 53 was. So that's what we're looking at here. All right.
Mark, could you excuse me a moment, please?
Sure.
Right back.
Okay. So now we're going to let this come in. We have one frame that was rejected, and I think that's because it was just 1 point higher. There. So I hope you guys are enjoying this. It's been a while since we were able to stream because Marianne and Tara, Rob in the chat, and Tara Diulis in the chat are both in our nonprofit group that does these remote observatories for you. And they went out to this observatory today. They're both in Arizona. I'm in Connecticut running this telescope 2,500 miles away. I'll be there tomorrow, however, because I'm leaving Connecticut tomorrow evening. And I'll get there at 10:30 at night, Arizona time. And so, yeah, there we go. See? The numbers are good now. Yeah. And so I will be out there to do some work toward the Benson, Arizona Observatory that we broke ground on last time I was there. And we're gonna take a different approach because we're gonna actually have an enclosure that will cover the telescope and some small area around it. It's not going to be a building like this. It's going to be a separate enclosure, and it's going to be a pop-top building. The whole top is going to lift right off and come down on the side, and that's going to be using linear actuators. So these linear actuators are going to be able to pull the top right off, and it will allow us to have unobstructed views to the horizon. Now, in astronomy, we don't usually view to the horizon, I grant you. But there are some things we want to view near the horizon. And even though we know they're not going to be looking that good, we're going to want to try it out anyway. So that's what we're going to do. So this is Messier 3. It looks really pretty. Let's try zooming in. Wow, look at that. That's pretty. Now, remember this, because when we talk about another globular, I don't know if we can get to it yet. We're going to find out. It might be pretty high in the sky. We're going to find the altitude of this. Oh, it's 46. We might be able to do it. We might be able to just do it. So this is yet another globular cluster. And this one is even closer. It's 25,000 light years away. And so the one we're looking at now is 32,000. We looked at one that was 58,000. And the Great Star Cluster in Hercules, Messier 13, is actually 25,000 light years away. Again, halo objects kind of orbiting the galactic core. Not outside the whole galaxy, but just the galactic core.
Would you say 25,000?
Yes. 25,117.4 according to this here. We know this is never usually 100% correct.
Okay. I don't know where I got 13 at.
Because of Messier 13.
Wiki says 22.2 thousand light years, but
Okay.
what's a few thousand light years between friends?
Uh-huh. Ronald, what's happening? That's ERRT Radio. Make sure you listen to Ronald's channel. And you can go to ertradio.com, I believe. Right, Ronald? Yes, Ray. We'll have a horizon view, but obviously we will be seeing cactus and trees if we go down to that level. Might make for some really cool photos, you know, if they're far enough away.
This is M13 now?
Nope, this is M3.
Oh, still, okay.
Yeah. Yep. So we're checking this out, and I'm gonna save this. This is 18 exposures. It looks really pretty. And save exactly as seen. So remember, Messier 53 was smaller, right? So 53 was smaller in overall diameter for that core. Excuse me. And 3 is bigger. And that's because it's 32,000 light years away. Messier 53 was 58,000 light years away. So now we're going to go to a cluster that is 25,000 light years away. Just a little bit more, closer now than even this cluster. So that should be pretty interesting to see the difference. All right. And so that's what we'll do. We'll go check that out. We'll save this. This is 22. That's actually a good Messier number 2 for another globular cluster, Messier 22 in Sagittarius.
Oh, yeah. A little early for it yet.
Yeah. Okay. So that's this beautiful cluster.
Can we zoom in a little bit on that before we go?
Sure.
When we look at Messier 13, it's a little closer, but it is intrinsically a much larger globular cluster.
Yeah, you're going to see the heart of it's going to be even bigger than this right here. There's the heart of this one. And then the stars start to it'll level out and get distant. Okay. We can zoom way in too, just for fun, right? And I gotta tell you, our skies are somewhat degraded right now because there's a big brush fire out there. So our imagery is actually a little bit degraded right now because of the fire. Because we do have smoke in the air. Even so, it's not that bad. Smoke and full moon. And still, we can deliver it. Dang it. Very cool. Okay, we're going to leave this here so we can compare it quickly. So that's that guy. And now, we'll go back to our low light view.
Ronald, I didn't know you had a YouTube channel now. Can you post a link to it? What's it called? Just ERRT Radio or?
Yeah, thank you, Ronald, for letting us know about your YouTube subscribers. I think you should, put up your link so that we can actually share it with the world. And this is our night camera view here. You can see the moon is causing quite a stir. Okay. Okay. So we come back here and we should already be on Measure 13. We're going to do this. Center it up. And of course we have Measure 92. And let's now go to Measure 13 and see that we can see it. Telescope's going to lean way over and look out into the direction. There it is. That worked. So this is one that's even closer to us. And we're going to go to the west now. I'm sorry for my cough, guys. I have bad allergies, and I'm a little stuffy too, and it's not going to be any fun to fly with allergies, but it's alright. Once I get to Arizona, they'll vanish. And we may stream when we're there, I'm not sure. We're definitely going to stream from Contact in the Desert. Okay. Okay. Much richer cluster, as you can see right off the bat. Much richer. Okay. Let's see where we are here. That's pretty good. Not bad. Not bad. Okay. As before, 12 seconds. I'm sorry, 15 seconds. 15,000 milliseconds. Okay. And get rid of that. And now, when I bring up the live stack, you'll see the previous picture we took of Measure 3. So there's 3. See the size? Okay. I'll clear it. And you'll see now, instead of a size like this, it's going to be something even more phenomenal. Look at that. Okay. Okay, so let's now
I see the propeller.
yeah, I'm going to clear it because I want to center. Actually, I don't have to. I did it anyway. Well, that was dumb. Okay. Alright, so we'll do this again. Okay, so we rejected a lot of them. We're going to clear and start again. Start again. Okay, we rejected that first one. Wind could be picking up. There we go.
If you see the very center of the cluster, folks, and then look to about 8 o'clock to the lower left, there are 3 dark bars making a propeller shape, and it's called the propeller, oddly enough.
I'm outlining them right there. But if you need to see them, there's one here, there's one here, and there's one here. Oops, I went a little too long, sorry. But there's the propeller right there. One down there's one thing. That's how it looks. Let me let me color correct first. And then let me take the black level down and darken it up like it needs to be. Here we go. And you'll see that 15 seconds is really long and it's almost too bright in the center. So we're going to take our mid-level curve and drag it this way to reduce that central brightness, and now look what you get. You still see the cluster really bright, but the stars are now visible as individual stars. That's much bigger than Messier 53, and it's substantially more than Messier 3 that we just saw. But you see, you can do your own comparisons.
I love globulars. Every one is different.
They are. And to your story down in Mexico, Florida. Yeah, just type your question in here, and we'd love to answer it for you. You know what? I'm an astronomer, and I believe that extraterrestrial life has made it to our planet. It doesn't get any more nutty than that. I've been fighting the arrogance in academia for decades. So go right ahead and ask. I can promise you there's no one here that's going to say you're crazy. Because I asked every crazy question going into astronomy. I can promise you that. Okay, we're going to just darken this up a little more. That's really pretty. I love this orange star. These orange stars here are just, they really punctuate the scene very nicely. Let's zoom in here. We got 12 shots done. Look how rich that is. Oh, okay. Yeah, see, your story. Not a dumb question. I just talked to some. Actually, I was on I think I was on Coast to Coast with George Norrie a few nights ago, and I was on for an hour with him, and we talked in part because a caller had a question about Nibiru, and basically from the science, there's no evidence that there is something that massive outside our solar system that's influencing any of the other planets. There's evidence that something is out there that's influencing our planets, maybe something of the size of Pluto or a little larger. So there might be a planet 9, okay, out there. I think Pluto's a planet, by the way, so I would say Pluto a planet 10. So a planet 10 could be out there, all right? So as far as whether that's something like Nibiru, the doom planet that would, like every few million years it comes into our inner solar system, had there been such an object, it would have disrupted our solar system long ago. But the stability of our solar system is such that nothing like that has presented itself evidentially. Okay, so we don't see any evidence for it. We do see evidence of objects moving and perturbing Uranus and Neptune and Jupiter a little bit. But those are, when we estimate the mass, we're looking at something that's like another potential Pluto-sized object out there. So nothing major out there from what we can tell so far. Does that
I
mean that
saw-
there's absolutely nothing? No, it doesn't. It doesn't mean that at all. Go ahead, Daryl.
I saw a recent estimate. They said it might be about 5 Earth masses.
Yeah. But that's, again, we would notice that perturbation, and we don't see it yet. So you got to keep in mind that objects out in the Oort cloud and out in the Kuiper belt would be reacting as well. And I don't see that in the data right now. We don't see that.
I thought there was. They think they are seeing something, but it's perturbing some trans-Neptunian objects.
Yeah, no, I was just mentioning that there is something out there, but they're not saying that it's a planet 10 or a planet 9 by the new definition. They're suggesting that it might be an object, perhaps another Pluto-sized body, maybe a little larger than Pluto, and maybe more rocky, yes, than Pluto. So, but right now, there's no evidence for Nibiru. See that, your story? It's not like you ask a dumb question. You've sparked discussion. He also says, is the asteroid belt a destroyed planet? Actually, no, and I'll tell you why. The asteroid belt was a smaller planetoid that never formed because Jupiter was disturbing it and tugging on the components that would have made it. There's the other planetesimals during the early formation. If you add up all the asteroids and you push them all together, Ceres, the largest, Vesta, the next largest, and you take them all and you push them all together and make an object out of them, do you know that object would only be 1/4 the size of the moon? That's the kind of mass we're talking about. So the asteroid belt, people think they see in books, it's like all these many asteroids. Well, it's only 1/4 the mass of the moon in objects, so that's really not that much. So it wouldn't make a planet. It would make maybe a small moon. How about that? Isn't that crazy? And there's moons in this solar system that are as big as planets in our solar system. Who knows which one it is? And Daryl's not going to tell you the answer. If you know the answer, okay, we're looking for the moon. There's a moon in our solar system as big as a planet. Which one is it? All right. So here is a beautiful Messier 13. That is really pretty. And this is a keeper. Let me see if I can tease out a little more contrast here without losing too many stars. This might do it. Look at that. That's beautiful. I mean, you can just hear the roar of the stars, Ronald says Titan. That is not the answer I was looking for. You know the answer I'm looking for, Daryl, right?
Probably.
Okay. All right, so let's save this. Okay.
Is it Titan actually bigger than the planet Mercury?
I will tell people the answer.
Starts with a G.
Yep. It does. It's one of Jupiter's moons. It's one of the 4 Galilean satellites. It's the 3rd furthest out from Jupiter. All All right, now I'm going to save it. No takers out there. Ganymede. Come on, Ganymede. It's Ganymede. That's the one that I was thinking of. Ray, within the atmospheres of the stars, the sound waves measured within the atmospheres of the stars are just colossal. And yes, within a star cluster like this, yes, you're not going to hear sound. Obviously, it's a vacuum, duh. But I do think that you get into the stars and, you know, you listen to the roar of the stars. That's what I think of. And so, you know, thinking of it from a romantic point of view, as you go by the stars, you hear, you know, as you're going by. Kind of like sci-fi. It's kind of cool.
Sounds like the chicken heart.
Who said that?
Oh, you got to be old to remember that reference. It was
Okay.
Bill Cosby comedy routine back in his stand-up days
Oh, wow.
in the 1960s, the chicken heart.
All right. All right, we're going to get out of this guy for now.
Never mind.
You know, that's okay. I was just ending that. I had to throw that in there. I don't remember the chicken heart routine at all.
I heard it
Okay.
when I was in the Cub Scouts.
I remember the dentist. You know? That is smoke in my mouth. What? That is smoke in my mouth. Remember your lip was all like hanging down because they numb you. So he did a funny routine about it.
Yes.
Fiber, that be fiber in my mouth. All right, so that was cool. So we just saw 3 globulars that are really interesting. And what we'll do now is we're going to go back to the comet briefly because we're going to see if it changed positions. And we know that it did in the time that we have been away. Comets are these objects that actually show you how dynamic the universe is because you can see the movement in just a few minutes' time. Daryl's rummaging for something. I should have muted you. I didn't know you were going off to do something. Okay, let's... I don't see the comet in here. I wonder if is it not in here? Maybe I'm off a little. As the moon is rising, it's getting brighter, and it might actually be interfering with the view of the comet.
Yeah.
All right, what am I going to do? I'm going to just take a 10-second shot and see whether I can see it. Let me get rid of this. Then do this. It's beautiful. All right, let's see. All right. It's not in there.
Blimey.
Oh, wait a minute. Hold on. Let me just go and pull it. There it is. It's down below. Okay. I knew he had it. I was like, making me go nuts here. All right, so it's down here. All right. And we'll be able to see that it has moved since the last time we were looking at it. So let me pull it up now. Here we go. There it is. Okay. I forgot I had zoomed in, guys. My mistake. Izabela, it's gone.
Good story. No Earth-based telescope can see anything man-made on the moon. Image scale is way off and too far away, and the scopes aren't big enough.
Even the Hubble Space Telescope can't see anything there because the sensor on the Hubble Space Telescope is made of its pixels, and the typical landing site on the moon would literally be fully contained within 1 to 4 pixels of the sensor, nowhere near enough to create a legible image. That's a study I did years ago, actually. Okay, 15,000 milliseconds here.
The Lunar Reconnaissance Orbiter can see the lunar landing sites, and like the LEM, the landing stage for Apollo,
Yeah.
stuff like that.
You can see tracks left by the astronauts and rovers. You can see individual experiments left on the moon. You can see all the crashed stages that held the lunar module in it, that they crashed into the 5th stage, I believe it was, that they crashed into the moon's surface to let the seismic sensors that they also put on the moon detect it and help build a compositional analysis of the moon that way. And there's something else that not many people know about. You can see the lunar modules that were discarded after they crashed into the moon. They left long paths, miles long, of debris, and you could see it. And where do you see it? You can see it on the Lunar Reconnaissance Orbiter Quick Map. LRO Quick Map. All one word. Look it up. And you will see exactly what I'm talking about. It'll take you to all the locations on the moon where the lunar module that was in a spiraling orbit hit a lunar mountain, and it's like a balloon that popped, and when it popped, it was just like and scattered everything in mile-long track onto the lunar surface. Boy, I wouldn't want to be in there when that happened.
I had occasion to share the LRO Quick Map on Reddit recently. Some guy posted a picture of a crater with a thing in the middle, and he wanted to know what that thing in the middle was. Whether it was a crater with a peak in the center.
Mm-hmm.
And we explained to him that I don't know if you'd call it fluid dynamics or what, but some size asteroids or meteors make a big enough hole, they get a rebound effect in the center, and that's what makes the peaks in the middle.
Yeah, I tell people it's a bloop. Bloop where water comes up in a splash.
Yeah.
Yeah. But in rock, it lasts a few fractions of a second. Sorry, go ahead.
I posted a link to the NRO. And I told him the name of the crater was Theophilus.
Oh, yeah.
And pointed out that showed him how to find it on Lunar Quick Map, and everybody was ooh and ah. They'd never seen it before.
Mm-hmm.
Pretty cool.
Yeah, it is. Yeah, I've
Theophilus.
good.
Go ahead.
I was gonna say I've done several streams on the Lunar Reconnaissance Orbiter Quick Map, so you can look. We got 450 sessions or more up there. Several of them are on the LRO Quick Map and how to use it. It's really cool. So feel free. It was 80 here today, and now the temperature's dropped precipitously.
Uh,
So,
with upper 70s here, and it's doing the same thing. A cold front's coming through right now.
yeah.
Supposed to be in the 60s tomorrow.
Yeah.
Boy, the crazy weather we've been having. The Midwest has been getting really bad. You know, the tornadoes all over and stuff.
Oh, yeah.
We're just kind of getting the backwash of the storms. And we had a hailstorm in a little burg up in far northeastern Colorado Monday, I think it was.
Mm-hmm.
Like softball-sized hail, and it
Oh,
was
wow.
supposedly killing cows and horses, and absolutely destroyed a lot of cars and severe damage to a lot of houses.
I can imagine it would be pretty dangerous. I've been pelted with hail the size of little marbles, and it hurt like you couldn't believe. See, hail's not just round, perfect spheres. It's these conglomerates of ice, and so it can be kind of bumpy and lumpy, and it hurts. Oh.
I was sitting on the porch late one night watching a thunderstorm. This is back in Missouri before I ever moved to Colorado, and
Yeah.
I was sitting out there watching it storm, and it started hailing, and all of a sudden I heard a big kerplunk out in the yard, and I saw one land, and I ran out and grabbed it, and it was the size of a baseball,
Wow.
and luckily it didn't hit anything. I was so proud of that, I put it in the freezer and
Yeah, I
saved
did.
it.
I did the same thing.
And my mom wound up throwing it away. She didn't know what it was.
Yeah. Well, my whole family witnessed the ping pong ball sized hail that was falling outside, hitting the roof, denting the cars, cracking windows. And so I grabbed a bunch of them, put them together in my shirt, ran inside, and put them in the freezer. And it looked like a stack of like frozen little ping pong balls inside the inside there. We're getting closer to that galaxy. Not tonight, but maybe another night coming up. I think it's going to go above the galaxy, though, but that's pretty cool. Neato. Let's go and case the joint for some other cool things.
Moon's right next to Antares.
Yeah, it is. I don't believe it's high enough to see.
Yeah, probably not. Still early there.
It's only 16 degrees above the horizon. Yep. All right. Okay, so what we'll do from here is we're going to come back this way. Uh-oh, I just yawned. You know what that means? Yeah, these are the Virgo cluster. I was thinking while we're here, we might as well check something out.
Lubo would probably teach you the right way to say that comet's name.
Oh yeah, hey Lubo, nice to see you. Oh yeah, this comet is this guy right here, A3 Suchinshan Atlas. Your story. Thanks for coming by. Hey, make sure you subscribe. And if you get a chance, you can always check us out at skytourlive.org right up there. You can check out our Patreon. We also have a SkyTour shop right here, which is Etsy. All these pretty pictures that are in hyper processed and made beautiful are put on blankets and sneakers and boxer shorts and mouse pads and lampshades, and you can get them. And it all goes to support us, because I'm not making anything on this. This is a passion rather than a job. So please support us if you can. We'd love to have you. So have a good night, and thank you for coming up here, Story. Good to see you. Okay.
Mr. Django says T-shirts? ?
Oh yeah, we got T-shirts too. Sorry. Yeah, we have skytourlive.org. We have our logo, and on the back it says the universe live in real time. We'll be selling those T-shirts in person at Contact in the Desert out in Indian Wells, May 30th to June 3rd. Yes, June 3rd. That's the conference. Man, it's like 3 days. I got to do 4 lectures. I'm doing a Skywatch where people found out that Ben Hansen and I are doing a Skywatch, and the first time in history they rented buses they rented 2 big tour buses to take people out to our Skywatch. It's Ben's Skywatch. I help him. But when they found out that Ben and I were doing it together, the buses sold out, and so now the organizers are like, oh man, we should have got 3 buses, maybe 4. So that's cool. People like science; they just want to learn more, and I think that's what's really cool. So hopefully we'll get. And by the way, at Contact in the Desert, thanks to Calabos and Tiffany, 2 of our super user volunteers, they give us equipment, and we're the exclusive giveaways for Celestron gear, Celestron telescopes, and binoculars. So when I'm out there, we're gonna give away 2 telescopes during my lectures, and at least 1 pair of binoculars. Right, so I'm doing 3 lectures where we're going to be giving away equipment. My first one is going to be a pair of binoculars. That's Friday. The Sunday night Sky Tour, we're going to be giving away a telescope system. And the Monday lecture, we're going to be giving away a telescope system. Okay, Lubos said that it looks like it might have been pronounced the same way as I said it. Suchinshan Atlas. Sorry. Okay.
Sometimes it's all speculation on my part. On the Sky Live, they call it TSUCHINSHAN Atlas, Comet C 2023A3.
Yeah, this. Suchinshan. Yep.
Actually, it may be what is it? A CH sound chain,
What's that?
like Sing Tao beer isn't.
Oh yeah,
pronounced
the
Sing-
TS is
Sing-
like Tsit. It's like Tsu Sushinchan Atlas. Something along that lines. I used to work with Chinese, and so they were always criticizing how I was pronouncing things, so I kind of learned a little bit from them. Oh, Izabela, thank you. Izabela put up the Contact in the Desert speaker bio thing, which is very nice. Thank you. Okay, this is I'm gonna say this is Comet C/20. No, I can't do the slash. 2023 to Shinshan dash Atlas. Okay. Michael Hedrick has a question. Mark, what's that cool fuzzy thing? Right at the star in front of the comet. Oh, that's a galaxy right there. And that's what I've been saying during the night, that the comet is heading this way, so it's sort of heading toward that galaxy. It'll be kind of cool if it's going to cross in front of it. I think there's one right here that is going to cross in front of it. I've only done a short exposure here. This is literally only 15 seconds. I mean, we could try to do a longer exposure. I guess we can try it. Alright, let's try this. Let's go up here to our exposure box here. And let's do 25 seconds, okay? There we go. And now we'll save this. And save it exactly as seen. Now we'll clear it. Do a 25-second shot. We're only at 150 gain though, so I want to change that. I'm gonna go to 200. That means I gotta start over because it's not gonna be good enough. So you never change the settings. You should never change the settings in the middle of a shot. Okay. Okay. Clear it. Now we'll get this back now. This is our starting point again. All right. We can also do the annotation. Let's see what it knows here. Let's have it do a plate solve. It's going to solve for objects in our view. And it probably won't know the comet, but it will know some of the stars, possibly. So it says plate solving in progress. Yes, Lubo, this is the F2 setup right now. Yes, are you using the F2 setup right now? Yep, we are. Okay, no deep sky catalog objects in the view. 6 objects, including a star from the Hipparcos catalog, HIP 60172, just out of the view. And that view extends obviously above and below here. So we're in a pretty unexciting location in the sky right now, except for this beautiful comet. That's cool. Nash A is with us. Hey, Nash. Says, what type of telescope is this, please? I want one to keep it outdoor and monitor through my computer. Yeah. This is what you're seeing right above here. That's a 10-inch Meade LX600 telescope. And the whole roof of the building comes off and on in this particular setup. Our new one's going to be like a clamshell. It's going to open up and expose the whole telescope to the sky. That's the Benson, Arizona. It'll be the second SkyTour West site. We're doing one here in Connecticut. It's going to be another one of those shell opening types like that with linear actuators. And this one on the East Coast is going to be a solar observatory. So we're going to be able to see the prominences of the sun every day. I should say every day it's clear. And that's really pretty. Really, really pretty. Okay, let's see if we can... Now, since it's a 25-second shot, let's do this. Let's darken it up a little bit. And let's drag this down. That'll give us a better view. So this galaxy is really bright right now. That's the galaxy right there. Luba wants to see the Cat's Eye Nebula.
We always ask for the cat's eye.
Did we look at it last time? Were we able to see it?
I don't think we looked at it yet.
Okay.
Cat's eye is in Draco.
Yeah, and I think that's down low right now, isn't it?
Let me find out.
I'll be finding out right here anyway. I'll just look for it. Cat's Eye Nebula. Oh. Lubo, you might be in luck. I think Lubo's in luck. I think we're going to be able to see it. All right,
it's
Lubo.
a little higher than the North Star.
Yeah. And since we can see the North Star and slightly below it, we can do it. All right, Lubo. Well, it might not be that exciting with the full moon, but we'll check it out. What do you say? All right. Let's come back in here and save this.
Whoops. Stellarium changed my location again.
Oh, it did? All right, so...
Yeah, it's been doing that.
Huh. All right, so we're going to get this out of the way. Come in here. And go into our little light view. All right, we'll try this. Let's try the Cat's Eye. Okay, it's gonna lean way over. See it leaning way back. It's gonna be close. There it is. I think that was it. Yeah, I think that's it. Right there. Alright. It's definitely got a lot of oxygen 3 in it. That's why it looked green. So we gotta be careful when we take pictures of it, because we gotta drop the gain down to low levels. And we're gonna take I'm gonna set the gain to 100. Probably should go even less. And then we're gonna take our timing and let's Let's see if we can do what Lubo's asking. Again, at F2, it's kind of hard. With the Celestron 11, it'll certainly be... No, we do have a filter, Lubo. It's actually quite a nice filter, in fact. It's a UHCS filter. We have a full moon out tonight, and we're able to see faint galaxies and things like that because we're cutting through most of the moonlight, but we can't get all of it. Okay, so now what we're going to do is, see how it's green? You can definitely see that. So we're going to bring this as close to the center as possible. And the center, that's good. Alright. Alright, so now we're going to just do a 10-second shot. I'm actually going to drop us down to 50 here. What's that right there? I wonder what that is. Alright, must be a satellite. Okay. Alright, so we'll live stack it now. Drop this out of the way. Okay. Now let's check it out. Izabela remembers we did the cat's eye here, and that was with the telescope that's behind me. The telescope that we'll have out in Arizona will be approximately the same field of view. Maybe a little, actually a bigger field, a smaller field of view actually better. Alright, let's see where we are. Oh, I see. Let's take this up just above. That's better. Let it try to figure out what it wants to have for the curve, and then pull this down. As you can see, that's even too much, but look at, you can see there's a haze around it. We were able to catch rings last time. See, he's got some here, right there. And let's let this develop a little bit. Let's pull this way down. And see, even 10 seconds is too much, but you want this other detail in here. So that's part of the problem. So you can see that there's detail in here. Mm-hmm. Okay. So the cat's eye is a planetary nebula, and when the star exhausted its hydrogen fuel, the core began to collapse. And as it did so, it got hotter and emitted more radiation, which pushed the outer envelope of the star out, causing the star to become a giant star, a red giant. Then, when the temperature got hot enough, it began to fuse helium into carbon. Our sun will do that. And when that happened, the star began to shrink down a little bit, and then finally, when it ran out of the helium to make into carbon, before it could get to the next step, the core collapsed even further. And at that point, the star grew into another red giant again. That's called the asymptotic giant branch. And then it started to collapse a little bit and bloat a little bit, and then collapse a little bit and bloat a little bit, as instabilities built up in the star as it started to fuse different items and shells around the core. And when that happened, it expelled lots of its outer atmosphere outward, and that's what you see around it here. Now, it's not really that surprising that we see oxygen here, and the oxygen will glow green. Ionized oxygen glows green, and the reason is because oxygen is the third most abundant element in the entire universe. First is hydrogen, then helium, then oxygen, and then carbon, the thing that oxygen is tied to the most. Well, Daryl, we got some outer detail here, yeah?
Maybe. I would think the moon can't be helping.
No, it's certainly not. You are absolutely right. It's not helping. And we also see I'm doing this to show that we're getting some noise in here too, this diagonal noise.
Yeah.
That is called walking noise. And we do have to worry about that. Lubo, we'll look at this object when it comes up a little higher in the sky and when there's no moon. But thank you for that, because that's kind of cool that we have that there to look at. I won't be taking any images of it though, because we don't have a lot of good data coming in here right now. Okay, so let's get rid of this. Okay, well, this has been fun, guys. And I think, let's see, while we're here, is there something we can look at as a last object right here?
I have an idea.
Yeah, go ahead.
Go to Stellarium.
I'm there.
And show Corona Borealis.
Okay, that's over here. You want to go look at T Corridor?
I was hoping to see if there it is. If your Stellarium had T in this database yet.
Oh, let's go see. Doesn't look it. What is there? Is there a name to the star?
No, just T Corona Borealis.
Yeah, no.
Oh well.
It doesn't. It. All I know is the right ascension and declination. And I know it's not one of the main stars.
No. If you zoom out a little bit, you can see the whole constellation there. It's kind of, I think it looks kind of tipped right now. T is sort of to the below the curve of the crown right now. The Corona Borealis means northern crown.
Is it like here?
And below the curve of the crown.
So below here?
Maybe a little to the right. Roughly that area. anyway, what they're saying is if you can identify Corona Borealis, go out and take a picture of it now, and then you'll have something to compare to when the nova happens.
Yeah.
Flipping the two images will be obvious. It'll show you which one is the nova. If you can find the bright star Polaris, Corona Borealis is just east of Arcturus.
You said Polaris.
Arcturus.
Okay. All right. Well, when T Core Bohr goes nova, we'll be obviously looking at it, and then we'll watch it change its brightness over a period of a few days to weeks. Novas are faster than supernovae because they result from an instantaneous fusion occurring on the surface of the star. What happens is it's a system where you have a red giant feeding a white dwarf, and if the white dwarf's mass is less than 1.44 solar masses, then you can feed gas onto the surface of that white dwarf to no ill effect. But at a certain point, that gas may spontaneously fuse if the temperature gets hot enough. And if that happens, then the entire star will flash this hydrogen gas and form helium quickly. And when it does that, then you get a momentary brightening of the star, which fades over a few days as the brightness and the fusion, the runaway fusion, stops. And if that gas does not make the star more than 1.44 solar masses, then this can happen over and over and over again, and that's what's going on with T Corona Borealis. The star is not reaching the threshold that will cause it to be completely disrupted and form a type 1a supernova, which is what happens when the white dwarf mixed with the red giant gets gas on it that increases its mass to beyond 1.44 solar masses. That's called the Chandrasekhar limit.
Izabela posted the coordinates.
Okay. Let's see. Can you read them to me?
Yes, 15 hours, 59 minutes, 30 seconds, right ascension.
Okay.
15, 59, 30.
Okay.
And declination, whenever you're ready.
Yeah, go ahead.
25 degrees, 55 minutes, 12 arc seconds.
What's the brightness of the star?
I think they said it's currently about 10th magnitude.
Okay.
They're thinking it may brighten to 2nd magnitude when it goes nova.
I love it. Okay, telescope's going to come whipping around now. There it goes. Got several hundred pounds whipping around right now in the sky out there in Arizona, 2,500 miles away from here. Okay, we're going to increase our brightness now back to 200.
If you plugged in the coordinates, will Stellarium show it now?
I'm going to actually do an annotation and see if it'll tell us what we're looking at. I wonder if it's that guy. We're going to find out. Okay. It doesn't know any stars. It knows Hipparchus catalog. Wait. Hipparchus 78 322 Blaze Star.
Izabela says that's one of its nicknames is the Blaze Star.
Oh, then it's right there.
Okay.
Let me actually do this again, because I think that when I moved it, it moved it off, and I think the Blaze Star is right here.
Yeah.
Yeah, here we go. All right, there's that's T Corbor right there. All right, let's take some imagery of this. We're going to get rid of this for a moment, and this is the star we want right there. Excellent. So we're going to move it over. Wrong way, Feldman. Okay. So this is the guy, right? Sam S says last went nova in 1946. Okay. Let's do a... now that we're in this field, let's do a 12-second shot of this field, and then we're going to come back and do a 12-second shot when it goes nova. But first of all, let's do one more thing. Let's solve again for this, okay? Because we want to make sure we have it correct. So it's going to be that guy right there where we want to place this. There we go. All right. So we're going to do this 12,500, so 12,000 milliseconds. Go into our live stack here. It's 12 seconds. And we will minimize this. Clear the stack. Lubo, we'll get back to the cat's eye in a future one. Okay, now here we go. And go. All right. So there is our Blaze Star. Thank you, Izabela, for those coordinates. I'm also really pleased that our annotation shows up with it. Okay, so now what I'll do is I'm going to let this stabilize. Pretty out the picture. There it is. Now we're going to call it T Core Bore and we're going to call it dash Blaze Star. Okay. And now what we're going to do is we're going to bring this back up. We're going to save the image with the annotation. So now we'll have it as an identifier, like a finder chart almost. Okay.
They seem pretty confident of their prediction. I mean, they were saying sometime between like a month or two ago in September, I believe. Of course,
Yeah,
by
history...
September, it'll be pretty far over in the west, I think.
Well, we'll still be able to see it though, and that's good. All right. All right, so this is the star then. It looks a little orange to me, but that makes sense because we're looking at a red giant. Now let's zoom in, shall we? Okay. there's our star. That's this star right here. And this little galaxy right there. That's neat. So it's orange because it's a red giant. Okay, and there's going to be a small... There we are. That's where I want to go. This red square, guys, this is our field of view. And if you turn your head so the writing is correct, then the field is correct. So we zoom in. I believe this is the star. Yeah, but it's not labeled in Stellarium. It's labeled in our product, though, because our product is smart. It is smart. Yeah. So there it is. And I like having this record of it. So I'm going to save this image with annotations again. Okay. Good. So now if we look at this image that we just saved, okay, this is what we've changed. This is what we got. Okay. So now we actually see what we actually took a picture of. So it's like a finder chart for us. And what we'll do is we'll save this.
Would you call the white dwarf a spectroscopic binary? It's too close that we can't see it.
if in fact we can't, yeah. I don't know how far away apart it is. I mean, again, at f2, but I don't think we'd see it if it was going nova. It's going to definitely be a spectroscopic binary because it would really be so close to the star. You know. But there we go. So this is going to be a really bright star in just a few more weeks, months, or whatever. And we'll capture it.
Thank you for indulging me.
No, that's actually good. And what I'm going to do is... okay, so
Izabela did all the work.
Star. That's good, though. I'm glad she did. This is a star that's about to go nova, guys, and we're going to be seeing that very soon. How far away is this star? How far away is this?
Give me just a second, I'll find out.
Okay. This is our last object for tonight, guys. Thank you guys for coming, by the way. Our return to streaming night was successful. Telescope's operating perfectly. Thank you, Marianne and Tara, for the work you did out there. Thank you, Izabela, for the app that you've written for us. Go ahead. I'm sorry, Dale.
806 light years away.
Okay. So when it does go when it goes nova and we see it go nova, it will have happened 800 years ago. 806 years ago. Very cool.
It's a nice chart of it at the article. I'll post that, a link to it in the chat.
Okay. All right, folks. Well, there you go. That is pretty cool. Thank you so much for coming with us tonight on our journey. We saw globular clusters of different distances and therefore sizes. We saw the comet one more time. And we saw the Blaze star. And we tried to see the Cat's Eye Nebula. Lubo is gone, but we tried, but we'll get it when it's higher up in the sky. All right. So thank you guys for coming. And we will see you again very soon. Why is this coming up now? All right. So have a good night. And we will catch you on the other side. So good night, everybody.
everybody.